A gigantic void could solve one of the greatest mysteries of the universe. The James Webb Telescope has found brand new evidence that the Hubble tension is real. This means we are once again breaking new scientific ground. The latest discoveries suggest that our universe may be constantly changing, something scientists had not anticipated. In plain language, this means that we know almost nothing about the true nature of the universe. Are we now back to almost square one with our research? Enormous voids millions of light years across present researchers with an unsolvable mystery. The gigantic voids should not actually be there if we believe Einstein's equations of relativity and our old cosmology. These old calculations can only have described one part of the universe. That much is clear because since the launch of the James Webb Space Telescope, we have seen so many incredible indications that there is more that we can only marvel at. Void structures are among the most incredible and fascinating structures in the universe. Their sheer size alone pushes our minds to its limits. The largest currently known void measures 100 million light-years in diameter. If a light particle were to start a journey at one end of the void, it would take 100 million years to emerge from the other end. And imagine further, within these voids there is practically nothing. In a space where otherwise hundreds or thousands of galaxies would be found, there is simply nothing. Our universe is actually crisscrossed with enormous filaments, structures that are something like internal cosmic lines of force, along which matter migrates. Galaxies move coherently with these structures, and even clusters of galaxies abound where the filaments form large intersections, thereby attracting matter. It's therefore reasonable to assume that there are fewer filament structures in the voids, and consequently less matter accumulates there. But that shouldn't be the case. The Hubble tension solves the greatest mystery of the universe. While it has been proven that our universe is formed by uniform structures, it remains a mystery whether these structures are homogeneous or inhomogeneous. Homogeneous means the same or even. Inhomogeneous would therefore be more chaotic. Now you might say, it doesn't matter, but it's not that simple, because a big decision about how the universe is really constructed and how it works depends on this small question. We humans still want to know what exactly the universe is in order to learn more about ourselves and the true nature of the space in which we live. Our previous ideas about the Big Bang and the expansion almost necessarily require a homogeneous or isotropic, that is, even, universe. This idea has been on shaky ground not only since the launch of the James Webb Space Telescope, because something that shouldn't actually be there was already observed in the 1990s. Since we have been able to see ever larger dimensions of the universe, we have been trying to measure them. You can probably imagine that this is not so easy, because measuring spaces of several million or even just a few thousand light years is no easy task. The dimensions are huge, and no one can just whip out a meter stick or use terrestrial GPS surveying. To do that, you have to imagine that everything in the cosmos is in constant motion. Stars move. Planets rotate around stars. Even entire star systems race through the galaxy and the cosmos at incredible speeds. Galaxies migrate and rotate, and we still don't know to what extent even the dark matter in the vast spaces between them moves and changes. Taking measurements here is a feat that our science has so far mastered with the help of light. We know from light that it behaves in a reasonably constant way. The speed of light was the only constant, that is, non-relative, quantity in the universe that Albert Einstein could find. So scientists took light quantities to measure distances. One of these quantities is the Cepheids, a special class of stars whose absolute magnitudes behave similarly in a linear fashion to those of type 1a supernovae, for example. These tools are called standard candles by scientists, and they were actually considered to be largely reliable until the Hubble tension emerged. Hubble was wrong, and today we know why. Edwin Hubble, the astronomer after whom the old space telescope was named, was one of the first researchers to describe the expansion and probable dimensions of the universe. Hubble was conducting research at a time when astronomers were beginning to see beyond the Milky Way. It may sound incredible to us today, But at that time, researchers still thought that the Milky Way was located in a huge void. It has only been about 100 years since we humans have known that other galaxies exist in the universe and that space is full of matter and many other cosmic phenomena. Based on Hubble's initial calculations of the true dimensions of the universe, further measurements were made. These showed a consistent picture for a long time, but then a measurement difference occurred at large distances, which became known as the Hubble tension. The Hubble constant was suddenly no longer reliable as a basis, and since then, scientists have been puzzling over how this measurement difference could have occurred. Imagine that, to measure a distance, scientists use a meter stick one time and a digital measuring device the next. Both results differ from each other, and yet researchers can find no fault with either the meter stick or the digital measuring device. So what is the reason? That is precisely what the Hubble tension is on a cosmic scale. Hubble's ideas about the true nature of the universe imply a homogeneous and thus largely linear universe. But now we are finding more and more evidence that this is not the case. Understanding the homogeneity or isotropy of the universe is easiest if you imagine an ocean. Technically, an ocean is a space or volume filled with water. Of course, many creatures cavort within an ocean. There are structures such as sea trenches or reefs, undersea volcanoes, and much more. On the surface, you would see waves, and even if it all seems chaotic, scientifically, it's isotropic. The recent discoveries by the James Webb Space Telescope and the vast voids would mean that there is suddenly a hole within the ocean where there is nothing. That's not possible, not here on Earth. But the voids in the universe are just that. If there can be holes or anomalies like the voids, then there may be more strange phenomena in the universe that our science is unaware of. The magic of these new discoveries is that we are now finding out that the universe is constructed quite differently than we thought. What is the real significance of voids in the universe? If voids are evidence that our entire cosmology is wrong, what is the truth? Did the Big Bang really happen? And has the universe been expanding ever since from a single point of origin? But then the universe would have to be isotropic, that is, homogeneous. Since the launch of the James Webb Space Telescope, however, we know that the universe is very likely not isotropic. Right at the beginning of its mission, the telescope showed us images of a large number of galaxies that existed so close to the Big Bang that they shouldn't actually exist. Their mere existence contradicts the rules of cosmology and the calculations of the age of the universe. Furthermore, the telescope saw an enormous structure behind the Pandora cluster containing several hundreds or even thousands of galaxies that shouldn't really exist either. This structure is simply too large to exist in a homogeneous universe so close to the Big Bang. The voids also contradict these rules, and just a few months ago, researchers found evidence of some huge radioastronomical structures that are among the largest ever discovered in the universe. According to the old rules of cosmology, these should also be impossible. In 2015, scientists found a group of more than 70 quasars that had gathered over a distance of 4 billion light-years and, as a group, also formed a kind of object that is still a complete mystery. Quasars are extremely bright galaxy cores that are thought to date back to the early days of the universe. At least, that's what researchers thought until now. But what if there was no beginning at all? Galaxies that are too old to exist according to the laws of our astrophysics and cosmology, structures that are too large to occur in an isotropically organized universe, and finally, the Hubble tension also tell us that we have fundamentally misunderstood the universe so far. A few scientists admit that despite our massive advances in research, we are probably only at the very beginning of understanding the true dimensions of the universe. What if we have really only scratched the surface so far? What if the universe is infinite? And what if matter or even light are not the measure of all things within the universe after all? What voids really are? It seems incredible what alternative explanations for our universe there are. It sounds crazy, but voids could be something like counterworlds in our own. They could also be dimension gates in which universes overlap. Researchers from the USA have found clues that voids could be dense in a multiverse structure. According to this, they would be relics of gigantic collisions of entire universes and dimensions. Some researchers even believe that voids could be inhabited by aliens that darken normally visible matter to extract energy from it. This is also based on a recognized theory. The idea of super civilizations comes from the Russian researcher Nikolai Kardashev, who in the 1960s provided scientific evidence that there must be highly developed species within the universe. These super civilizations are able to darken entire galaxies with their power plants. They can theoretically manipulate the laws of physics and even determine our lives without us noticing. Accordingly, voids would be spaces whose matter has been removed or altered in a way that is still foreign to us. Such theories and ideas sound fantastic to us, and yet they exist. They are all based on logical ideas, but they never found the recognition like other theories that eventually became our worldview. The fact is that the James Webb Telescope and the latest observations are pushing us to the limit of what we previously thought was true, and our science must now prepare for further shocks.